All right. Welcome, everyone, to my extremely niche, but hopefully very impactful in the future workshop about Appose, which is a new library for linking programs together. In particular, the use case that I want to highlight today is invoking Python projects from Java tools, especially Fiji. It can also invoke Python code from other Python projects. Pose exists in both Java and Python, and you can connect them however you like. I'll get into it. If you want to follow along with my slides, you can find them online here. I'm going to refresh my slides just in case, because I pushed something not that long ago. The only prerequisite for this workshop is that you have Fiji downloaded and installed and updated. If you don't have that, please feel free to do that. And if you don't do that, that's okay. I will still be walking through everything and you can just watch. So no pressure, no worries. Oh, and one other thing about my slide deck here. If you do load the slide deck, before I get into what Appose is, if you push the O key, or if you move your mouse down to the bottom left corner, you can see there are some controls here. This is SlideDev is the tool I'm using. If you push O, you can see all the slide outlines. So that's pretty handy if you want to jump around or if you get lost in the slides and want to figure out where we currently are. All right, so what is Appose? Appose is a tool that lets you connect multiple programs together. I call it interprocess cooperation with shared memory. So what that means is multiple programs talking to each other via some mechanism. In this case, Appose uses pipes, regular standard out, standard in, standard error pipes. Cooperation means that Appose gives you tools to help them work together better. So the really key thing is that it gives you an environment builder so that you can write a program that uses Appose to build the Python environment or Conda environment for the user so that they don't have to do it themselves. And then you can start Python or whatever program that lies within that environment. And finally, you can tell that program to run specific tasks. And then the other thing Appose brings is shared memory, because one of the downsides of interprocess communication and connection is that the processes do not share memory. So shared memory, though, is a mechanism that exists across all major operating systems to specifically set aside some memory of your computer that is intended to be used by multiple processes. And so Appose provides you with some convenience tools to allocate and manage shared memory and pass references to that shared memory back and forth between your programs that are working together. It looks like it hasn't finished. Oh, yes, good. Okay. So I want to quickly talk about what Appose is not, just to so there could be some confusion here, right? Because Appose we're going to be doing a lot of stuff with Python in this workshop. And there's also this new thing that Fiji has called Python mode. This is not that. The Python mode that Fiji has is running in the same process. So it's not an inter-process communication. It's you just start Java and you start Python all within the same program, essentially. And it works via the ImageJ library and the Jaunch launcher. There's a lot of good advantages to Fiji's Python mode. You can use this, since it's one process, you don't have this issue of memory isolation. So you can make a NumPy array on the Python portion and then just use it in Java. And we have tools to help do that. And you can also directly invoke method calls and so forth on Java objects from Python and vice versa using the JPipe wrapping. So this is, and then you can, in this Fiji script editor, you can go to the Python script language now and just write Python scripts that run on the Python portion of your Fiji when it's running in Python mode. So that's all great, but the downside is that you can only have one environment at a time. When you set up your Fiji in Python mode, which you can do in Edit Options Python, it's in the side, it will ask you, where does the Python environment live? And there's a button to create one, which creates kind of a standard nice one that has the things you typically want, like PyImageJ and maybe Napari and NDV and some things like that. And you can customize it, but you can only make one choice there. You have to say, I want these tools and not these other tools at these dependencies and not those other versions. And unfortunately, the way that the deep learning tools in Python have developed, they often are incompatible with one another, because you might have one like StarDist that relies on the TensorFlow version 1, and then you might have some other thing that relies on TensorFlow version 2, or different versions of CUDA is a really good example. Often you need CUDA libraries to run things on your GPU, because otherwise it's too slow. And you can install CUDA with CondaForge from CondaForge, but you have to pick a version. So if you have two tools that need two different versions of CUDA, then they can't both run in your Fiji at the same time. And so that is where Appose comes in. Appose solves this issue. It gives you multiple isolated environments. They can each have their own dependencies and each run separately. And so you could already do this by hand without Appose. You could, drop to your command line, and you could use Conda or Mamba or Pixie to build yourself a Conda environment somewhere, and then do it again and build a second one. And then in Fiji, write some script that uses Java's process builder to like call the Pythons in each of them. You can do all that, right? But it's a big pain in the butt, and it's different across different operating systems in certain ways that are important. And so Appose exists to try to like smooth out all these difficulties and make it as easy as possible for a Fiji plugin developer or a QPath plugin developer or Icy or Napari, whatever your favorite tool of choice is, your platform of choice, I should say. You want to build a plugin. Well, Appose lets you call out to an isolated environment to do the work of your plugin. So just to quickly summarize, interprocess means multiple processes, like I said, and that can be Fiji calling Python, Napari calling Java, or Napari calling another Python that has different dependencies. 2 Java programs, 2 Python programs, any of these things are possible. And it says Python R here. I don't have an R version of Appose, but making one probably wouldn't be so difficult. And you can still use Appose to start whatever other processes you want. It would be something we could develop as demand arises. Someone is working on a Julia version of Appose, for example. Then there's the cooperation part, like I said. The way that this works, the way that Appose helps you, is that it gives you these constructs, the idea of creating an environment object. This environment object in the diagram here is only one environment, but you can build more than one. So we could imagine this entire graph here, cut and paste it as many times as you want. So you can have an environment for running StarDist, and another one for running Cellpose, and another one for running segment anything, and so forth. Each environment gets built by Appose. This workshop is about how to write a Fiji script to use Appose to do all of this. And so what I will warn you all right now is we are not going to escape from the Python so-called dependency hell ourselves, but our goal is to help our users escape from it. So someone who is reasonably able to make an environment using Pixie or UV or Micromamba, you still have to develop that environment.yaml file or pixie.toml file or pyproject.toml file. But once you do that, you can bake that into your Fiji plugin so that your users never know about it. They don't care about it. They don't go to the command line. Appose just builds the environment for them. It will download Pixie, UV, or Micromamba on demand, stick it into its Appose cache, and then it will build the environment as you want. So everything should work out of the box on a freshly installed computer of any of the 3 major platforms. I will say asterisk, Appose is in development, and so it's not at 1.0 yet. In particular, we have solved a lot of issues with Windows, but there are still a couple of issues with Windows. So if you are on Windows today, you may hit some roadblocks trying to actually do the workshop hands-on with us, but you can try, and Appose it does work on Windows. I will demo some stuff that works on Windows, and we'll make everything work on Windows. I'm very committed to that. Okay, so then what do you do once you have one of these environments? Well, you start these worker processes, right? So each service/worker is its own program, its own process running separately. And they're all connected up to your main program via pipes, like I said. So it's essentially like a thing that, almost like a daemon that runs in the background, and it's listening for requests from your main program, which in this case will be Fiji, right? So your Fiji starts a Python oppose worker, and then a second oppose worker if you want, right? In our example today, we'll just do one, because you often only need one. But the point is that you can have as many as you want, and each one of these can spawn its own tasks, and the tasks each run in their own thread. That's a Python thread here, and as some of you may know, Python has some limitations with threading. That's evolving, but for the most part, it's still single-threaded, which means if you start multiple tasks, they'll sort of take turns to do stuff instead of using all your CPUs. But you can get around that by starting more than one worker process. Right, okay, so then the third thing is the running of the tasks. And the way that this works is it's a lot like side Java scripts, for those of you familiar with that. You just pass in some inputs, and then you can assign some outputs in your Python script, and then those will be can be received back by Fiji. And all of this is done via JSON. So it makes a JSON object, and it squirts that over through the pipes, and then it gets interpreted on each side. The only exception to that is the shared memory piece. So in order to not have to turn your whole image into JSON, we support the named shared memory buffers. So what a named shared memory buffer is, this is something that came with Python in 3.8. It lets you allocate, it's like an array. You allocate a big block of memory, but that block of memory has a name and an extent. And so, of course, it has an extent, all arrays do, right? But the name is important, because if you tell the name to your other process and what the extent is, it can wrap that same memory into another shared memory object. So you have Fiji with a shared memory, and you have Python with a shared memory, and the two of them are pointing at the same data. And if one of them changes the data, the other one will be able to see the changes with no copying or communicating necessarily. So in Appose, there's an extension to the built-in Python one. It's also called shared memory, and it just extends the multiprocessing one. The reason for that is just to give you some convenience functions, and in particular to know how large you actually, or that you requested. There's two sizes, okay? So you can say, I want shared memory of 6.2 megabytes or whatever, but your operating system might actually allocate a slight round up, basically. And so with the Appose one, it remembers exactly how much you wanted, and it also knows how much was really allocated. Okay, and then in Java, there was no Java shared memory thing that we could find. The closest thing is a tool called larray, but it doesn't quite do this. So we ported the Python shared memory over to Java, and it's part of the Appose Java library. So you get the same thing. You get a shared memory object, and it has the same functions as much as possible. So it's modeled after Python's. And in any case, the result is now that you don't have to serialize your images. Now that's great. Everything I just talked about is only still a one-dimensional array, right? I said you give an extent, right? But I would like to have NumPy arrays, please. So what the problem is that in Java, there's no NumPy arrays. We have ImageLib2 in Fiji, which can wrap NumPy arrays with PyImageJ in the same process. But for Appose, how does it work? So with Appose, we've also included this thing called ND array, which is just a triple of three things, right? It's a shared memory, and then it knows its D-type and it knows its shape. So it knows that it's a uint16, and it knows it's three-dimensional and the 2 channels and 20 rows and 25 columns or whatever. And then there's this confusingly named .nd array accessor on it that gives you back a NumPy array, and we should maybe rename it to .numpy array, because as is, it's ndarray.nd array, but this is the current API. And for the Appose today, this is what we'll be using. And under the hood, the way that has to work is we just pass the shim, which is the shared memory thing. It has a buffer, which is the actual data, to the buffer of NumPy. And when you use this signature, you can't give a shape, so then you have to reshape at the end. But you don't have to do this. Appose does this for you. So then in Java, this is all compatible with ImageLib2 using another library we've built on top called imglib2 Appose, which we'll be using today. So you use these two classes, shimImage and ND arrays. And you can just make a shimImage that wraps a given ND array that you made with Appose, or yeah, this wraps it to an array image. And you can also make a copy of an existing image you have that doesn't happen to be in shared memory, but you want to put it into shared memory so you can then pass it to Appose. So all these functions exist. You may want to come back to this slide later at the very end of our workshop, because these are useful hints. Okay, so at this point, I want to show you some of the things that we have already done with Appose and that we are doing with Appose, just so you can kind of get an idea of the power of it and why it's nifty. So I'm going to run my Fiji. And in my Fiji, I'm going to use SAMJ. Okay, so the first demo, I'm going to use SAMJ. This is under Help Update. And then you go to the Manage Update Sites, type in SAM, and you check the box next to SAMJ. You don't have to follow along with this part if you don't want to, but you can try to play if you have your Fiji up and running already and you want to try, and feel free. Okay, so mine already has SAMJ installed. Let's open some samples. Maybe organ of QWERTY is like this one. And then in my search bar, I'm going to type SAMJ and run this SAMJ annotator. So it pops up this little control panel. And here you can choose which SAM model you want, because there are several. I'm going to be using the SAM2 Tiny. I mean, they're all different as far as how fast they are and how much performance you get out of them. So basically, the bigger the model, the better the performance, meaning it does a better job segmenting stuff, but the slower it is. That's just a rule of thumb, right? So like if I go to large, you can see that the speed is 4 out of 5, but the performance is great, okay? But we're just going to use tiny, so keep in mind that the segmentation we get here is maybe not the best possible out of SAM, because we didn't use the best model. So if you're using SAMJ for the first time, when you click this little arrow thing and it pops over the sidebar, you'll see this install. It'll say it's not installed, and then you have to click install, and then SAMJ will download the model for you and cache it. I have this one installed. So all I need to do is choose which image I want to work on, which is this one, of course, and say go. And what it does is it does a little pre-processing of the image into patches to prepare the model. Oh, so here we have an error. I knew this was going to happen. Haha. It's not a friendly looking error, but we can read it and see. It says it only supports one channel, so that's great. What we can do is go to the composite mode and change to color and look at each of the channels. I can say, which one of these do I think is going to work well in SAMJ? Well, SAMJ is good at annotating, segmenting blob-like structures. So I think what I want to do is segment these guys here. So I'm going to duplicate, Shift-D, and not duplicate the hyperstack. So I only get this one image now. Cool. So now if I go in here and change it to that one, the -1, and say go, it'll do a thing. And it's printing out some debug output about what it's actually doing. So this is using Appose. These are the JSON lines that get passed to Appose. It's telling Appose to please execute something, and then getting back some update messages from that Python process. Okay, so there's a few ways of using SAMJ. One way is to click this big on/off thing and turn it to live. And then you have the rectangle tool, and you just kind of like select the things that you want to be segmented, and it will just do it for you because it passes each one into the model. So that's really nice. But another cool thing that you can do instead of live, which this is my favorite because you can write macros and scripts, do this, I think. The other thing that you can do is click on the multi-point tool and then preset prompts. And then you just make some points. So you could get these points via any plugin in Fiji. For example, find maxima yields a bunch of points. And then you just say batch, and then it's like, boop, all of them. So that's pretty nice too. So that's SAMJ. I think that the fact that all these different models are available, we could even add more models that require different Python dependencies, and it wouldn't matter, right? Because each one of these can use Appose to start its own, to create its own environment, start its own worker based on the settings that you use in this tool. And so that's pretty powerful that it's all just in one Fiji. Okay, For my second demo, I just want to show you what we're currently cooking in TrackMate. So TrackMate version 8 either just came out or is coming out imminently, like this week is being released. TrackMate version 8 is a big upgrade to TrackMate, but it's not version 9, which is going to have support for 3D segmentation. So right now in V8, you still segment slice by slice, and then you link your segmentations together to make the tracks for tracking. But with version 9, we have 3D and 3D visualization, and now Appose. So I'm going to show you what we just cooked up at a recent hackathon. This one would be harder to reproduce yourself, but you could, if you are comfortable using Java IDEs, you could clone this branch, import it into your IntelliJ, for example, open it up, and then you shift, and you can type in TrackMate plugin.java to find the TrackMate plugin classes. Plugins, Here we go. It still didn't pop up, but I have it right here. You can also navigate. So I am going to open up this C. elegans 3D data set that I have prepared and just run it. And you'll see what happens. So here's the data set. It's a 4D data set. It has multiple channels. And again, I'm going to hit Shift Z to go to color mode so that we can look at each channel individually. You have nuclei. And then this is, I think, ground truth, which we will not use, of course, for segmenting this in our tests. And then another channel, 2 different experimental channels, I think. And you can see it's 3D. So these are all round structures over, up and down through. And then through time, you can see, of course, that it's like some mitosis or some splitting going on. Okay, great. So here we are in TrackMate, the usual wizard interface. I'm going to click next. You can see here that in this branch, we have an Appose StarDist 3D detector. So we're actually going to segment this with StarDist 3D. That's tricky because there's no general StarDist 3D model. There was a generalized StarDist 2D model that everyone is using. But in 3D, it has 3D support, but it's hard to make a generalized 3D model. And so we're going to be using 3 models developed by Florian Levitt and his group, which he published and is documented in the Git repo. So when I hit next, you'll see that I have pre-trained models. These are the 3 models that are available right now, and we're going to use confocal. For our channel, we want channel 1. Using channel 2 would be cheating. We'll use channel 1. And these settings are already preset to be what are best for the model. So it knows the model is looking for nuclei that will be 39 by 39 in XY and like only 7 slices thick for nuclei that are like that. But this is, of course, a calibrated image. And so we have the micron sizes. So what will happen under the hood, this is not a fatal error. It's just a thing you can ignore. Here now, as you can see, it's doing a bunch of stuff. It's using Appose. These messages are coming back from the Python code that we wrote that uses the StarDist 3D, and it's going frame by frame. So it's probably really small to see, but it's, let's see, processing time 0.7, and then 8, and you can see each one's taking about 2 seconds. This is on my MacBook M4 Max, and it's using GPU acceleration. If you don't have GPU acceleration on your system, it takes more like 30 seconds per time point, depending on your processor. So the fact that we have GPU acceleration here is really slick. And I do want to show you one other thing quickly about this work. See if I have it. There's a pixie toml. I guess it's embedded. It's embedded somehow. Pose detector. Somewhere there's the StarDist 3D detector. Pose 3D. Well, here's the Python script. You know, actually, I know where I can find this, just to show you guys really quick. Okay, so here we have a Pixie toml. This is the one we developed for using StarDist in 3D. Pixie is great because it lets you specify platform-specific dependencies and also, of course, GPU dependencies for using things from Conforge. So you can see here it's configured differently based on what platform we're doing. And this is what my machine is, and so this is what's getting used here. But that means that this StarDist 3D has been tested now, I think, definitely, yeah, I think we got it working on Windows and definitely Mac and Linux and x64 as well. So that's great. All right, let's go back to our Fiji. Well, it's done. We will keep going. I'm not going to threshold anything or set any filters. This one, let's see, is that actually real? That does not look very real to me, but all the rest of them look pretty real. Let's just use the simple lap tracker. So now we have tracks, and you can see for at least a lot of them, they look really good. But what's really cool is that we can do the 3D view, and this is using the big volume viewer, which is an extension of the big data viewer to show things in 3D. So you can actually see all the segmented things. This is meshes. So TrackMate version 9 supports meshes and 3D volume rendering, pretty slick. So that's the second use case for Appose. And then the third use case, I actually won't end up showing you, but you can try it anytime after the workshop if you want to. The reason that I'm not going to show you this is because it doesn't currently work on macOS. And it's probably something that's already solved by a newer Appose, but there's a certain version that's being used by this work at the moment. When I tried to run it on macOS, it doesn't work. I think it's because it's using MicroMamba instead of Pixie. And so we haven't gone through and done the platform-specific tweaks needed to make it work on Mac, but we will. And by we, I mean Stefan Hahmann, the guy who is the mastermind behind the Mastodon deep lineage update site. So if you want to try it, you can clone the Mastodon example data and create a new Mastodon project with these guys. And then there's this command to actually manage the detectors and linkers. It's like a little GUI for building Appose environments. Unfortunately, on Mac doesn't work. I tried it, and this is the error that I get. And as you can see, it's just something that we need to tweak the dependencies for Mac. But again, this is something that you and me and other plugin developers will do, not users needing to do anymore. We test and solve it for the different platforms, and then it just works like SAMJ. Okay, so if you want to try it, here's the rest of the steps. It uses Cellpose, and then it also does deep learning tracking, which is cool. It uses Trackastra, so it calls that as well via Appose to do the linking step. And it should work well on Linux now. With Windows, you might get stuck on linking, but detection should work. Okay, so now we're going to get into the meat of the workshop, which I allocated about 90 minutes for, but I have to be honest with you guys, I do not know how long this is going to take us. It might be substantially shorter. If we end up falling behind, I'll just speed up, but I feel like we probably won't fall behind. Individual folks might fall behind if I go too fast, because I have a tendency to do that, but I will try to give you time to follow along. So what are we doing in this workshop? We're going to integrate a Python script / segmentation algorithm called unseg. Why unseg? I don't know. I just randomly searched for 2025 Python segmentation stuff, and I found this paper, or deep learning segmentation. I found this paper called unseg. I tried it. I was able to reproduce it really quickly. And so I thought, this is great, but you have to know how to use Python and build environments and all this. Let's do it in Fiji and make it for the world instead of just Python programmers. So yeah, you'll get a feel for how this works. And what's funny about this is it doesn't actually use deep learning. It uses a bunch of scikit image stuff because it's doing unsupervised segmentation, which I guess is fairly novel, but I'm far from an expert on this topic. It doesn't really matter, right? What matters is that we will build this tool and you will see how to build this tool, and then you can adapt it to any Python stuff that you want. So we're going to write a Groovy script. but the Groovy script is going to use Appose to call Python. So we're going to learn how to use Pixie a little bit, and we're going to learn how to make Python code that works with Appose, which is not super complicated mostly. And then we're going to learn how to write a Fiji script that can use Appose to call that Python script. And finally, we'll learn a little bit about debugging. So the only thing that you absolutely need, I guess, is Fiji, but I'm going to be doing everything from the command line because I like the command line, and you'll see why. These are the things I would recommend you have. If you're on Windows, I recommend Git Bash. If you don't have Pixie installed, it's easy to install. I'll give some time for that. And also, again, no stress. You can just watch, and you'll definitely get a feel for this. And this workshop, these slides here are very detailed. And so you can always just try this after the workshop as well with the recording or on your own. For your favorite text editor, you can even just use the Fiji script editor if you like. Okay, so like I said, you can try it with me or you can just watch. And if you get stuck, I've already done all of the steps and they're in this repository. You can go here and clone this repository. And then anytime you want to like jump to wherever we're at, then all you have to do is just check out the step that we're at, the step that we just completed, right? So step 3 is a tag that is solved through step 3. And the reason for that is so that you can say git show step 4, and it'll show you the exact changes that I made in order to complete step 4. There are going to be 15 steps, but they're all pretty bite size. So our very first step, the 0th step, is that we want to initialize a project. So we are going to make a new directory called unseg-fiji, and I'm going to make it on my desktop. You can make it wherever you want, but in a later step, I assume it's in the desktop, and so you might need to just tweak the path there. So make dir unseg-fiji, and I'll make my font just a little bit bigger just in case you guys have any trouble seeing stuff. Seg-fiji, cd unseg-fiji. And here I am, it's empty. And then we're going to initialize an empty Pixie project skeleton. So you need Pixie. And if you don't have Pixie, you can visit this link here. But I would recommend, I mean, you can use the installer if you want. The way that I have it installed is I use the releases from GitHub. So if you scroll down here to our releases or GitHub releases page, Pixie is just one binary. It's very light. And you can download whichever tar.gz or zip you want. So for example, if you're on Mac like me, then I'm going to get the Apple Darwin AArch64. I'm going through all these steps again, just in case anybody needs time to install this, because I did not say in my prereqs you need Pixie. So if you look what's in there, there's only one file called Pixie. It's just a binary, and you can put it anywhere in your path. So like in my path, I have Pixie, and I have it symlinked into where Appose installs it, but you could just put the binary here, and then you just have to make sure you do chmod plus x on it if it's not. But I think it should be executable by default. Okay. So here we are back in unseg-fiji. So now I'm going to do Pixie init. Copy that. You can click this little guy here if you want. Most of the commands you can just paste into your terminal. All right. So now what did it do? It made this pixie.toml. And what's in there, it'll be like author, you, channels, condaforge, name. Name is the same name as the directory you created. And then platforms will be your platform. This is a nuance that's kind of important later, but for the moment, it's fine. And just some version with no dependencies. Great. So now I'm going to use git every step of the way. You don't have to do this, but if you do it, you'll have checkpoints, just like I have in my reference repository that I mentioned earlier. And if you forgot where the reference repository is and you want it later, it's in CT Rueden. Telling you one more time, CT Rueden unseg-fiji. So this, I basically built this by following the steps we're doing right now. And I did these commits pretty much almost exactly like this. So now I'm going to do the same, paste, boom, done. And you can see there's a .get now. And if I do get log, there's the thing. And if I say get show, it has the stuff in it. Cool. All right, step 1. So now we need to get the unseg repository. So I'm just going to copy this and paste this. So what did that do? That cloned the unseg repository into a subfolder called unseg. We're not going to commit that to our repo. That's just something we're going to extract the algorithm and so forth from. And then the other thing you may notice that it did, so it copied out this unseg.py. The cool thing about unseg, well, this is good and bad, right? So the bad thing is they didn't publish it on PyPy. It's just, it has dependencies that are described in requirements.txt like many Python projects. But if you want to use it, you have to clone it and just use it. But the good thing is that it's just one script. It's about 1,600 lines, yes, but we don't have to understand all of it because we're going to call it via Appose. And you can see that what it uses is just NumPy, scikit-image, and scikit-learn cluster. So these are the requirements. And then it also has a Jupyter notebook, which we'll get to in a minute. So I copied that .py script out of there into my project. And I also unzipped the image folder because the repo comes with an image.zip committed, but it doesn't have the TIFF uncompressed. So I just uncompressed it. So it's right here. And if you want to see what that looks like, see here. Let's try. Just open it up in Fiji quick. So this is the normal gallbladder tissue image that we will be using because that's their test image. I did test this algorithm with some of the other images. They have a large data set published on, it's linked from the paper, and the paper is linked from the Git repo. And then you can download TIFF files. You have to create an account on this certain platform and get them, but they also work. They're all 1,000 by 1,000 and they segment pretty well. So after the workshop, feel free. All right, so that step is done. And as I explained, we have the segmentation algorithm itself, 1,600 lines. We have the notebook that actually has invoking it as a library, requirements we're going to need, and finally the sample data, which we just uncompressed. Here's our checkpoint. So now I'm going to select that, paste that. And that's a problem. It's an error because I actually have to say get add on seg.py. My bad. So now it's added. Git show. There's that thing. Cool. And you'll see Git says that I'm doing Git status to see this, by the way. My C alias just does clear and then ls and then Git status. So those guys will not get committed. Great. So now we want to convert this Jupyter notebook into a simple Python script. And there's a tool called nbconvert we could use. You could also use an AI assistant to do that. Or what you could do is do it by hand. So I guess I'm going to try both. If we go up here to the repo and we click into the run unseg, GitHub has a nice rendering of Jupyter notebooks. So you can see here it loads the image and then it does the segmentation. And when it does the segmentation, it prints out a bunch of output about what it's doing. And then you can see the segmentation here and here. And it looks decent for some definition of decent. Okay, so what I'm going to do now is just grab these cells through here in a text editor of my choice. I could use TextEdit, but I think I like Vim, so I'm going to say vi run.py. Paste those. Not going to paste the image, of course. I just want to paste what's in the cells. If you're already using your AI assistant to do this and you've done it, then you're awesome. Good job. Just doing it by hand so that you can see you don't need an AI assistant to do this. do, and this is not even doing anything, but we'll just put it in there for completeness. Cool, saved. So we don't need that anymore. Save as run.py. If you've never seen an AI assistant, by the way, then I'm going to show you really fast because I'm running Claude code here. You just type, let's see. Just type Claude, and it says, hi, welcome to Claude Code. And then you can say, please extract the cells from the onseg, the .ipynb file in onseg folder, saving as Python script named go.py. Claude Code Pro costs $20 a month. Claude Code Max costs $100 a month. I pay for Pro, and I get about 4 hours of use a day, which is more than I usually need. So for the low price of $20 a month, I can just have my digital assistant do this kind of grunt work for me. Yes, please create go.py. Done. All right. So now what I'd like to know is, did it do a good job? But I already did it by hand, so I can diff go.py is what it did, and run.py is what I did. That's pretty darn close. There's a little white space differences, and it didn't put the leading header. Otherwise, it did exactly the same thing I did. So that's a pretty handy tool. We're not going to use that tool much for the rest of the workshop, but just I want everyone to know about it because it's a game changer for programming, especially if you're not a CS nerd and you just need to hack your stuff together for your PhD. Okay, we got our checkpoint. Let's see here. And I'm going to have the same problem here. I need to get add run.py first, and then I can do my checkpoint. Great, it's added. I'm going to delete the go.py because run.py is fine. All right, moving on, step 3. So the next thing we need to do is figure out our Python environment and construct an environment file. So in this case, we're going to use Pixie because it's the most powerful and it's good to know how to use it. And we've installed it. So there's this command. It's a scary command. It has a bunch of flags, but I will show you how I figured it out actually. So what we know is that in unseg, there's this requirements.txt, right? So I want to say Pixie import unseg/requirements.txt. And it's like, I don't know what kind of format that is. Well, Pixie's being pretty stupid here because it's literally named requirements.txt. But if you do, how did I figure this out? Pixie import help, right? And I just read this and I was like, okay, there's an option called format. What format? This is what it's called, py.txt. Okay, great. -- format, py.txt. This is another weird error. It says it doesn't know which environment to use. But the thing about Pixie, if you look in, let's see, the .pixie folder, there's nothing in here now, but I know enough about Pixie to know that it makes one environment by default named default. And so unless you're specifically doing something that requires more environments, just do it to the default environment. So there, now it did it. And you can see it modified the pixie.toml. What did it do? It just added a PyPy dependencies section. This is from not CondaForge, but from PyPy. These ones would be from CondaForge or other Conda channel. And it has them all pinned to exactly the versions that they're listed as, which is great because we want reproducibility. All right. So now we can checkpoint that. We don't know if it works yet, but we'll be testing that very soon. All right. Git shows the changes that I've done. Awesome. All right. So now we're going to go through and adjust the dependencies. We could test it first. And in order to test it, what you do is you use Pixie run, because what that'll do is it'll take the Pixie toml, it'll set up it. If it's changed, it rejiggers your environment to be whatever's currently in there. And then you can run the Python of that environment. So this won't be the Python you have on your path. It'll be the one in the .pixie folder. And we want to run run.py right now. So it says there's no Python interpreter. So we should add one. That's exactly the step we're doing right here. Now, I happen to know that we need at least 3.9 for Appose. We could let it install 3.14 or 3.13 or whatever, but I'm going to pin it to 3.9 because this unseg project, I believe I think 3.14 is too new. And I ran into that problem when I tried to use it. So just to dodge that bullet, we're just going to go ahead and use the double equals for Appose. The double equals says, I want exactly this version. The single equals says, I want some version that starts with 3.9, but it can be a subversion of that. We don't actually need Appose yet. If I could have just done Python 3.9 and then run it. So now I'll run it. But I added Appose because we're going to need it later. So now it's added. The first time you run this, it's slower. And it's because it's downloading dependencies. Actually, I'll just use a different tab to showcase this. So you can see it's made, oops, it's made the usual Python site packages. You can see there's all this junk in it now because Pixie was busy doing it. Okay, it's running. So you might recall, if you were looking carefully at that Jupyter notebook, that it had multiple plot commands. So the first plot command just shows the figure, matplotlib, the figure with no segmentation. And it blocks till we close it. Once we close it now, it's going to start doing these steps. And it was pretty fast. I think on my Linux machine at home, it took longer, like 10 seconds. But looks pretty nice, segmenting the blue objects. And then here is a different segmentation for, I think, the red channel. So it does both. And if you're interested, you can see that it does both. We'll get into this later, but it's hard-coded to work on two channels, a nuclei and a cell membrane. You could, of course, tweak the code to change this if you need to, but we won't be doing that. Okay, so we added the dependencies, but and then we tested, right? But the other thing that I want to do is I want to move some of the dependencies to be used from CondaForge instead of PyPy, just because that's generally a best practice. And on at least one platform, I think I ran into some trouble solving the dependencies. So you can take all those and just paste them over here. And then try it again. And now Pixie will rejigger. Why? Interesting. Okay. There's no CondaForge package for OpenCV Python. So we'll put that one back in PyPy. And if you need to, you can, of course, rm-rf.pixie, just wipe out the whole thing and let Pixie rebuild it. It will be faster the second time because it caches all the downloaded packages in a separate place in the Pixie cache, which is not in this folder. It's still important to optimize solving and all that for our users, right? So the longer the solve takes here, the longer it's going to take when Appose builds it for them in the plugin, when the plugin's running in Fiji. When the more stuff you download, the longer it takes. And so we're currently working on a user interface, I should say user interface components for Appose that will let Fiji show a nicer, prettier looking build messages and like a nice graphical progress bar and so on, instead of just the console puke that you get right now. But that's not ready yet. Okay, so our script is working again. Still not using Fiji, but it works with the dependencies now from CondaForge. So we've done step 2. There might be an issue. I got an error on Linux about Qt where OpenCV Python didn't work. And I had to change the dependency to be OpenCV Python headless. So I'm also going to do that now. Even though I'm on a Mac and the non-headless one worked for me, I just know that it won't work on every platform. So I'm going to switch it to that and we'll give it a go. Still works. Da, da, da. Very good. And there's our checkpoint. Copy that thing, paste, go. Now you'll notice there's also a pixie.lock. You may have heard of lock files. It's essentially a complete record of the exact versions of everything. What's cool is Pixie does it for every supported platform. So right now, because my pixie.toml only says platforms OS X ARM64, the lock only has that. But if I put in here OS X, I forget what it is, Linux 64, let's try it. I'm actually just going to run Python to force Pixie to do a recalculation here. There. Now let's look at the pixie.lock again and see if it put Linux in there. Yep. So now Linux 64 is also listed in the package. Of course, my OS X is still here too. So what you want to do when you're developing a Pixie toml is you want to target every platform that you want to support. Right now, Fiji supports 6 platforms. It supports Linux, Windows, and Mac, and it supports each of them with ARM64 and x64, x86. So you can put all 6 in here. I think I tried putting all 6 in here for this project, and I found 5 of them work. The reason being that Windows ARM64, there are fewer things that are built natively for it. The reason is that if you have a Windows ARM64 machine, it can run x64 stuff out just transparently. And so you mostly don't have to have the ARM64 builds. It's just for speed. So anyway, for now, I'm not going to keep this change. I'm just going to switch back to my single. Well, no, I'll keep it. Git commit -a add Linux x64 architecture. Oops. Why does it say? Oh yeah, -m. Cool. So now that's not part of the slides, but whatever. It's something that we did, or I did. Step 5. We're currently we've done 5 slides and we're about 25 minutes into the presentation. So we're doing about 5 minutes a slide. I think that some of them might go faster though. So the next step we need to do is that unseg.py, as you saw, it runs great from the command line, but it doesn't know anything about Appose. So we're gonna tweak it a little bit to be more callable by Appose. And the first thing that we need to change, open unseg.py in your favorite text editor, that if you search in your favorite text editor for the word print, you'll see that it has a bunch of print statements. That's fine for a prototype. But Appose uses the standard out for sending messages. And what we want to use is the Appose task mechanism. So the first thing that we're going to do here is not even anything Appose specific. We're just going to generalize how this program reports progress. So I've written this little extension here, which we'll just put right here. So I should probably put it down here under auxiliary functions. So we have a global called report, which is a function. It's the print function. But if someone calls listen and passes their own function, a callback function, and it'll replace that with theirs. So that's cool. But then the other thing we need to do after we've pasted that in is we need to replace all of the print with report. So I'm just going to search and replace. I could do it manually here, like, but I'm going to use Vim's port thing. So just whatever text editor you're using, it's search and replace all occurrences, print to report. So now I've done that. And if I look at my diff, you can see that I've got my little listen guy, and I've got all the prints are now reports. So if I run the script again, we'll see it still works. And it still is printing stuff because we didn't call listen. It's just using that same function. We've primed the pump for being able to change it later. Now we'll checkpoint that. So we're going to have callback invocations accessible to us. All right. Now we are going to make our lives a little simpler, because when you call something from Appose, the easiest thing is to have a complete script that you're going to call. And that script can import stuff from your environment. But like I said, unseg.py is not a package that's been packaged and installed into our environment. It's just sitting there outside our environment. And so you could keep both .py files and put them in the right places and have one import the other one still. But for simplicity today, what I'm going to do is I'm going to take this run py and I'm just going to paste it at the bottom of unseg.py. Because if you look into open unseg.py again in your text editor and jump to the very bottom of the file, you can see that this is some function we're in. It's actually the main function, nuclei cell segmentation. There's not really anything main-wise that's going on in this program. So I'm going to add some blank lines, and I'm going to write, well, begin main program. And then here I'm just going to read in run.py. And of course, it has more imports and redundant imports and all that. And you can clean that up later, but right now, who cares? Python's fine with it. So we're just going to leave it like this. Oh, these need to be comments, of course. Good. Yeah, so that's it. We pasted it there. Save and quit. So now we have a modified unseg.py, which when diff just has the run.py at the bottom of it. So it bundles everything together. Standalone code, we can just call this one.py file from Appose later. We can run the test again, except this time we're going to run unseg.py because it's actually the main program. C run python unseg.py. Yep, still works. Do you see a pattern here? This is something that every time I train a programmer, I always reinforce one thing, and that is working state to working state. So whenever you're developing anything, you get it working first, the simplest possible thing. In this case, it was just run the unseg the way that it is from the repo. And then you make small incremental changes. And each time you save a snapshot so that if suddenly it doesn't work, you now have a very clear idea of which step broke. And you can also roll back your changes. So Git is just an amazing tool for that. And yes, it's worth the learning curve just for that. Okay, it worked. We're going to checkpoint that again. So you'll notice this is two commands. We remove the old run.py first, and then we unify all the code into one script. So, oh, it didn't actually remove it. Oops. So we can commit amend. Okay, good. And now deleted the run, modified the unseg, everything's unified. Fantastic. All right, step 7. This is where we need to make some tweaks, a couple more tweaks to the script. And hopefully it'll become clear why as we're doing it, because we need to be able to pass images in from Fiji. So we're going to set up our script to be comfortable with that. We're not going to checkpoint yet, so we have to do it. So to do this one, in our main text editor, we've got unseg.py. You can see here that I've got a lot of code. You can copy and paste it if you want, but just note that the plot image, there is code here. I just put the ... so that it would fit on the slide. What we're actually doing is not that complicated. We're going to just move some code. So you can see here this function called openimg, and it does two things, right? It uses imread to read the file, but then it creates this other NumPy array called intensity with the two, like it extracts the two channels basically. And then it returns a pair, the extracted thing and the original thing. And this is not considered good programming practice in the sense of each function should do one thing. So this is conflating two things. It's called open image, but it really is like open and process image. And we won't be using ImRead when we use Appose, but we will still need to do this other step. And therefore, we're going to take that code here. We're going to cut that code. We're going to only return the img now. And you can even just change it to say return whatever if you want. And then down here, somewhere we're calling that open img function. That's right here, but it's not going to return the intensity anymore. We can open it and plot it still, but then we need to do this other step, select intensity channels. So that's going to be this. And it's called im, the name is the same. So this code doesn't even really need to be changed. You can see it's just the same code down here. I'm just going to copy that comment because I like this comment. It's nice and descriptive. Tidy up my spaces, and that's it. So I will check my diff before I commit. Save and quit. My diff shows that I removed the code from the open image, and I moved the code down here. That's great. And I took care to change my return type here. So we should probably test it. Okay, runs. And it's running. I'm just going to hit Control C because it's clearly working. So it's fine. Okay, copy that, paste that, and saved. Step 7 complete. For step 8, now we're going to start to add in some understanding of Appose's existence, basically. So far, nothing we've done is actually imported Appose or used Appose. So we're going to add our first block of code that does that. This block of code is going to make a Boolean flag called Appose mode so that we can make the program still work exactly the way that it currently works. That way we can keep testing on the command line if we want, if we ever make changes in the future. This is important because whenever you're developing something with Appose, you shouldn't be developing the script in your Fiji script editor, the Python script. You should be developing it in Python. And then when it works in Python, only then do you try to call it from Appose, because otherwise, when things go wrong, you don't know, is it because my Python program is wrong, or is it because there's something wrong with how I'm invoking Appose? And so the way we're doing things here by sticking to Python for a while gives us that flexibility. And this block of code here allows us to retain that flexibility. So essentially, the reason this works is because our program doesn't have a variable called task in the globals, which is the primary no indented part of the program. But when it runs via Appose, it will. Appose injects this variable. It's a special variable. It's an Appose task, and that is what you use to essentially communicate with Appose from your script. So you can say task.update to send updates, or you can say task.outputs to manage the dictionary of outputs at the end of your program. And so what we're doing here is if we're in Appose mode, the task object exists. We're going to, instead of printing, we're going to invoke task.update, this function. So everywhere that it says report now will be a task.update call. But if we're not in Appose mode, then what we're going to do is something called a mock. We're going to, well, it still is a real task. It's a task object, but it's kind of a mock because it's not actually communicating with any calling process. It's just kind of a dummy. And that way, if you want to, you can also put task.update or task.outputs or whatever you want in your script, and it will still not crash. It'll just be like, I just do nothing. I assign the outputs, but they don't really do anything, and that's okay. So I need to actually do this now, and then I can do the checkpoint. Okay, seg.py. So where does this go? Well, I think I'm going to put it at the beginning of my main program. Maybe here. Doesn't really matter that much. There we go. Diff it. It's there. test it. It runs, and did it still print stuff? Still printed stuff, so we're all good there. And now we got our checkpoint. Sweet. Okay, so here we go on to step 9. In step 9, we're actually going to start making changes to the script to read inputs and write outputs. And before we proceed, I do want to point one thing out. This right here, task.inputs image, is wrong. Even though I'm the one who invented and coded Appose, I forgot that inputs aren't passed via task.inputs. There's just a variable, whatever the variable name is, it's just there. Appose injects it. It's more convenient than this. So we're going to go ahead and put this code in here, but then in a later step, we'll fix it as part of our debugging. So here we need to make sure we get the image from the correct place. Let's do that first. Once again, we're in our text editor. And we know we opened the image somewhere. That is right here. So you can search for OpenImg. We only want to do OpenImg if we're not in Appose mode now. And actually, I don't really want to plot the image either, because the plot.img, when we're in Appose mode, would invoke matplotlib, and so then the matplotlib plot would pop up from Fiji, and we don't want that. So here I have removed this img equals OpenImage, and I've shunted it down. But I notice it's image. I think it needs to be img. That's another bug. I'll fix that here. Okay, so if we're in Appose mode, we're going to grab the thing from the task. And again, this is wrong, but we'll fix it later. And otherwise, we're going to do what we did before. So that's great. That's step 1. Step 2, comment out plot calls or make conditional. So that wasn't the only plot call is the thing, right? There were a couple of them. So if you search for plot.img, you'll see here there's this else. I think I didn't, if not Appose mode. We'll do that. And if, well, you know what? Instead of doing it that way, let's just say if Appose mode return. Good. That's cleaner. And then where we were doing it below, it's here. This guy doesn't have to be in the else anymore. Oops. Okay, so you can do this to your taste, but I've now disabled the plot image for any time it's called. If we're in Appose mode, it just won't do it at all. So that's step 2. Looking good so far. Step 3, set outputs. So for this one, we need to, this is correct. There's a task has a special dictionary called outputs, and you can assign whatever you want to it. And we're going to assign the results of our segmentation. So mask nuclei, mask nuclei. So that gets given back by this function call right here. And then these plots happen. Then this other thing could be done. And then finally, at the very end, if we're in Appose mode, now pass the segmentation back to Appose. Back via Appose, I should say. So we'll save them into variables called nuclei and cells. Cool. All right, so now we've done all the steps that we're receiving inputs from Appose and we're passing outputs back to Appose. And we should probably test it again. It works. It's working. Okay, it works. Very happy. Oh, I ran, what happened there? I don't know. Ah, there's a bug here. Did you notice how it just started running it twice? We're importing from ourselves. That is a step I missed earlier. Nuclei. So we took that out, and now it'll only run once. Okay, got it, and done. Perfect. All right. So here I'm going to get, well, what's my checkpoint? That. And I'm going to say, and fix run twice bug due to add import. Okay. That's bad practice to commit 2 changes as one git commit. Like I said, working state to working state as small as possible. There's a tool, git add-p, that can help you split apart things, but I want to keep moving in the workshop, so we won't dwell on that. Step 10. So we're already on step 10. The workshop has about 45 minutes left. We have 6 steps left. So 5 times 6 is 30. So we're easily going to finish in time. We'll probably have time for questions too. All right. So now finally, we're getting to Fiji, right? We're going to launch our Fiji. Char Fiji. Oop. And then we're going to say file, new script. There's a handy shortcut for this, which is the left square or rectangular bracket key, which also opens the script editor. Your script editor, when it opens, might look a little different than mine. You might have this file explorer thing. I always collapse mine because I never use it, but you can use it if you want. Okay, so you'll see it says active language JavaScript. Well, that's fine, JavaScript is fine, but we want to write in Groovy. Language, Groovy. If you have never written in Groovy, don't be scared. It's very Python-like. It's quite Pythonic, actually. There will be only a couple differences. And as an aside, if you run your Fiji in Python mode, like I talked about at the beginning, when you do that, it will say Fiji is just PyImageJ in the title bar. And then under languages, when you click on Python, not Python, Jython, but Python, it will work. Whereas if I do it, it's going to say, oh, that's weird. It didn't give me an error. Usually it's supposed to tell you that you need to be in Python mode. Okay. And then you could write in real Python calling another real Python. Or you could write in Jython. I thought about doing this workshop in Jython, but the problem with Jython is that it's Python 2, and print statements don't have parentheses, and there's some other things that just kind of bother me about Jython. So I just decided to do it in Groovy. Works fine. It works really well. It's a lot simpler than writing in Java because you don't have to write your types. Okay, so we want to declare our inputs and outputs as side JavaScript parameters. And if you've ever written a side JavaScript before, this will look familiar. You put this #@ symbol, and then the type of your input, and then the name of your input. And then for outputs, you put the #@ output, and then the type of the output, and then the name of the output. So this should look familiar because we wrote task.outputs nuclei, task.output cells earlier. So we're going to stick to the same naming there. So I paste that in. Now I'm going to make my script editor a little bigger. All right, cool. And then I'm going to save. I'm going to save this into my unseg Fiji folder as unseg Fiji.groovy. It's kind of a redundant name. You could just call it unseg. Fiji ImageJ has some preference for scripts having an underscore somewhere in the name, and so I kind of artificially am calling it unseg Fiji instead of just unseg with no underscore and then having potentially some issues later, like not being found in the menu structure, things like that. I think it might find it anyway at this point, but just for backwards compatibility with the underscore. Okay, so I did that. I saved it as unseg Fiji.groovy. Of course, this script doesn't do anything yet, but you can run it now. Let's run it. You can click run, or you can hit Control R, Command R. You'll get this error that says img is required. because it has an img input. This is an ImageLib img. If I open an image, like Shift B to open blobs, I promise we won't segment blobs though. You can run and you'll see that it ran and it says blobs.gif. Because if you have an image open and it's your active image, then it will be fed into this automatically. Of course, we didn't actually assign anything to our nuclei. But if you did output string greeting, said greeting equals hello, see if it works. Yeah, and the greeting pops up in a terrible window, but it says hello. Okay, so those outputs get automatically displayed by Fiji. And in this case, nothing was displayed because they're null, because we haven't defined them. But it works. Our script is working inside Java stuff. Git add unseg Fiji.ruby. And then we will git commit that thing. And done. Step 10, we have the seed of our script. Let's move on to actually starting to use Appose in our script now. So when you use Appose, the main entry point is just the class called Appose. This gives you access to the builder. So I'm going to copy this whole thing, go back to my Fiji. I'm going to paste that in there. And you'll see it says paste entire pixie.toml contents here. So what we need to do now is open up our pixie.toml that we already made. So I open that in the script editor, select everything, copy, and then I can close it again. Say, no, I don't save, and then just paste. So now I have defined an inline string, which is the content of my pixie.toml configuration. It's all in there. And then the way that the builder works is you say Appose dot, and then what builder you want to use, Pixie in this case. And then you say, and I want you to build an environment from the following environment definition content, this pixie.toml. I'm going to pass this log debug thing, which is supposed to do print statements as it builds. I'm not sure it actually will show down here, but it's good practice in general to, while you're developing your script, put the log debug. And when you're done, when you're finally done and your plugin's awesome and you're ready to ship, then you might choose to delete it once you're sure everything's working really well. There's also a function you can subscribe output, and then write a function in here, one message or whatever, right? But that's more complicated. Log debug is like a shorthand for just like print out all the output and all the errors and all the progress as you're building. And then .build actually says, now do it. That's the so-called terminator of the Fluent construction here. And what it returns, .build returns an environment file, an environment object. And we're going to save that to an object called env. I'm going to run this. Of course, I still need to have an image open. I think now, because I don't want to be doing blobs all the time, I'm going to open while I wait for it to build. Mine built quickly, but that's because I've built it already. Once you build it once, it will build quickly, but you're probably still waiting. And once you see build complete, it'll give you the path to where it put the environment, just in case you want to destroy it and rebuild it, or look into it, peek into it. Another way to destroy it and rebuild it is to change build to rebuild. If you call rebuild, it will always nuke it first and then go back to, and then remake it, which still will be faster. Quit this. Still will be faster because it's already downloaded and cached the packages in the Pixie cache. I need to lost my train of thought. Oh yeah. I guess we can check some of this now that it's working. Or we can just checkpoint. Perfect. Now I'm juggling 3 things: browser and Fiji and the terminal. I didn't save it. This is a gotcha of the script editor. You have to hit Control S or Command S, and the little asterisk needs to disappear. Okay, because you can run scripts that are currently in dirty state and it'll still run the dirty version of it. Okay, now it looks like I have my changes here. Perfect. All right, environment build complete. Hopefully your Pixie is chugging along. If you're on Windows and you got an error about cannot find Pixie version, then there is a workaround. You can create a folder called .local.share.oppose, and in there, make a folder called .pixie, and then make a folder called bin, and then just download and extract Pixie from GitHub. Releases in there. If you do that on Windows from your home directory, then when you run Oppose, it'll get past that. That's just a glitch we need to sort out. Okay, so that's step 11. We've built the environment, and we know where it is, and you can inspect it if you want to. Keep in mind if you inspect it, by the way. So in here, .local share oppose, this is all our environments by default. There's the unseg Fiji. There is a way to override and put this folder wherever you want. I think eventually it'll be like envs in Fiji, because Fiji, everything else with Fiji is kind of self-contained in the Fiji folder, and I'd like to have stuff in envs. But just for development here, it's fine to let Oppose use its standard thing. One thing to watch out for is that all the packages are put into this .pixie folder, same as with the project we were developing, and that's a hidden file. And so if you use tools like tree, then it'll look like there's nothing in there. So you have to actually give the .pixie. There's a lot in there. Okay, so now we need to read in our Python script, step 12. This is starting to cook here. So down here, we've built the environment, but what we want to do is read in Groovy is // for comments, Python script. We could embed it the same way we embedded the Pixie TOML, but it's long, right? It's like 1,600, oh, it's more than 1,600 lines of code now. So I would like to just read it. So I'm going to copy this. And this is where I have a hard-coded path right now. So if you made your unseg Fiji folder, project folder on your desktop, like I did, this code should just work. And if you put it somewhere else, you can just change this right now to be wherever you put it. And we're not going to do it in this workshop, but there are, of course, many ways of loading resources from jar files or, finding it in the Fiji folder or whatever. We won't do any of that, but you could do that. And that is what I would do if I were trying to make it real nice for production. Okay, I got to open up the guy again. Nope, not that guy. I need to actually be in my Fiji and go to my unseg Fiji.groovy. Paste this. Oop, there you have a nice comment. So we have the path to it, and then we're going to read it in Groovy. This is nicer than Java. You can just call .text on a file object, and it just reads it, gives you the text. So there we go. And then I just put this sanity check here to print out how long it is, because it should be like really long, right? It shouldn't say like 4 characters. It should say many characters. So we'll run this again. Oh, I remember what I said I was going to do. I was going to open that other image file. This one. Yeah, because that's the one we're going to try segmenting. So let's leave that over here. Over here. And it'll just be there. Okay, so it loaded the unseg script. The length is 71,000 characters. That sounds believable. We can even check it if we really want. WC, a POSIX system. And it says it's 71,671 characters. So perfect. So we got the script. We're not doing anything with it yet, but we got it. And I saved my Groovy file, and I see that my diff has the changes. And I will now checkpoint. All right. We got 3 steps left, and we have 30 minutes total, so we should have enough time. All right. Committed. Now, in order to pass images back and forth between Oppose and Fiji, or Python and Fiji using Oppose, we would like to use shared memory. You can pass images, but you can't directly pass an image. If you try to pass an image, you'll get some cryptic error about JSON serialization. That is something I want to improve right now with Oppose. And I would like to make it so you can just pass images, and it will just under the hood do this magic here. But for the moment, it's a bit clunky. These ND array objects I talked about earlier are the thing that you can pass. So you can't pass an img, But what you can do is make a shim-img, which is a shared memory backed image, and get its ND array, and then pass that to Appose. So what I'm going to do, just to make our lives easier, is I'm just going to take these two functions, and I'm going to stick them into my script. Again, eventually, I would like this to be more like shorter, but for now, this is what we're going to do. So here, I'm just going to say define helpful image wrangling functions. And this one is, we have Java img to pose in the array. Actually, it's really in Java imglib to img. And then this other one takes an Appose ND array as input and gives us back a Java imglib2 array img backed by shared memory. And this one is not necessarily shared. Okay, cool. Save. I'm going to run my script again just to make sure there's no errors. There is an error. That you can ignore if you ever get one of these. It's like a script editor bug. But this is a problem. I'm going to just do that, see if it helps. Because I had this issue before and I don't really know what the problem is. All right. Oh, I do. I do know what the problem is. The class is called ND arrays, plural, not ND array. So this is a bug in my workshop. Here, we run. Okay. So it still runs, which means the syntax is fine. And I saved my script and I do a diff and I see that it's there. And I have a checkpoint. Committed. Step 14. We're getting so close. Almost done. So now here we're actually going to run our thing. Finally, we're going to run it. All that prep work for this moment. I just cut and pasted that in. Here we're going to say execute unseg. So I put some print statements here, and in Groovy you have to say print lin. If you say print, it'll print, but it won't have a new line, and then you'll get like a bunch of stuff mashed together. Print is the same as Python saying end equals empty string. So print lin, just to make sure that we kind of know what's happening a bit. Here's how this works. We have our environment. We say .python to start a Python from it. And then we set up our input map. We have our images input. And yeah, image is the name of it. It's an img. We feed it to our img to Appose that we made here, which is going to first copy it into an img that is shared, and then grab the shared memory and the array metadata object out of it. And that's what we're going to give back. And I also have this print here just so we know that it worked. You could, of course, get rid of that and just say return shim img, whatever, but kind of like the verbosity while we're developing. Once we've set up our inputs, that's all we have to input. You'll notice I'm passing it as a variable called ND array, because it's not an image, right? It's not a NumPy array. It's an ND array, an Appose ND array. We're going to feed those inputs, and we're going to run our unseg script. It's a new task. And this is also a Fluent API. The task won't start until you say wait for. You can also say start, and that'll start it asynchronously. But I want to start it and then wait for it to be done, because in this case, I really just need to call Appose once, and I can't really do anything until it's finished. So I say wait for. And if the script fails, wait for should throw an exception. If you say start, then you'll have to check yourself by looking at the task.error and task.status flags. Okay, this listen thing is a debugging thing. as you might imagine. This registers a callback. And in Groovy, instead of it being like Python where you say lambda it colon, you have to use curly braces. The lambda syntax is just a little different in Groovy. So I say listen, and this is a function, but yeah, this is telling it I'm going to be passing this as a function. If it, which is the implicit input, so I could put it arrow, but I'm just leaving it off. If the event, the update event, has a message attached to it, then I want to print the message. And I want to put this prefix unseg so that I can see it. So I know that's where the print is coming from. It's coming from Python. Okay, and then when the task is finished, we'll see this print statement. The status should be complete, or it would have thrown an exception. This error should be blank, but just in case it's not blank, we print it. And then finally, we're going to assign our outputs. So this is the key step with SciJava scripts. We actually declared that these are going to be outputs. So we have to assign something to the nuclei variable, to the cells variable. We can get our task outputs nuclei, but what are we going to get from this? Well, we're going to get another ND array, another oppose ND array, because that's the thing that we're allowed to send. And then we want to take that oppose ND array and turn it into an ImageLib image. So that's where this other nice function that we made comes in. So now we've done our adapting and assigned to the outputs. And then we put it in a try. It's the same thing as a try in Python, except the syntax has curly brace. Finally says, even if there's an exception thrown, even if wait for fails, I want you to do this. And in fact, we're not really doing anything here. It'll terminate because it'll exit this service here. The Python object will exit the service, and it gets cleaned up. It gets closed. So you don't have to worry about closing your services if you use a try. We might want to clean up something here, though, like to do free shared memory objects, ? Because one thing is if you make shared memory objects and then you don't delete them, they're outside any one process, which means Fiji can shut down and those shared memory things will just be sitting around until you reboot. And so this is a thing we may want to do in the future, but we're not going to do it right now. All we're going to do here is make a commit. I'm going to commit call unseg code via Appose. Sweet. And we're going to run it, and it's not going to work. And then we'll debug it, because step 15 is fix bugs. Okay, so we see that it got to copying the image into shared memory. And the array is null. So to start debugging, we just start reading the errors. We just start trying to fix it. This is not even the same error that I have documented in my slide. I think this is yet another thing. So unseg Fiji Groovy, line 53. That's right here. Interesting. So maybe the ND array that we're feeding into it, or are we calling oppose to image? Well, that's coming back out. Image to oppose. Is it null? You can put some print statements. That's usually the fastest way to figure stuff out in the Fiji script editor. Input image, $image. You could also do input image and then the plus sign. Groovy is more lenient than Python with stringifying variables, but it also has this nice interpolation syntax, kind of like F strings. So we'll just show output. Ooh, task object has no attribute inputs. Okay, so actually I did get this error. This is what I mentioned earlier, that was wrong, right? The unseg.py is calling a dot inputs. So let's go back to our favorite text editor, Vim, and open unseg.py. And then we will find where we put dot inputs. So I said this is wrong. Actually, there will be a variable called image just in there. It won't be called image. It'll be called ND array. So here's some hints. Task inputs are not available from task.inputs. We just talked about that. The Groovy script is passing a variable that's called ND array. It's not passing a variable called image. So here we need to say ND array dot ND array. Very confusing, but this is an Appose ND array converting into a NumPy ND array. Okay. Comments welcome on making that better. Let's look at the rest of our hints before we give up, or before we try again. We will use ND array to obtain a NumPy ND array. We're doing that. We're doing that. That's this call right here. So that should be good. And then the other thing is we need to transform input and output images on the Python side as well. Because when we're, okay, if we try to run this, it'll get further. But we're going to run into problems because we're passing back mask nuclei and mask cells. And these are NumPy array labelings. So I know that they're 32-bit int labelings in NumPy array, and they are not in shared memory. So to convert these to shared memory ND array or return as shared. We got to do that now. So this is the final bug. And to make life easier, I'm just going to copy. Well, there's two final bugs. I'm going to copy that, and I'm going to paste those in here. Of course, I could put those up in my functions if I were being less evil. So the first thing we need to do is share as ND array these guys. But that's not enough. And the reason it's not enough is because NumPy arrays and ImageLib images have opposite dimension orders. So in ImageLib, if you have an XYZ image, and it's like 512 by 512 by 3, then ImageLib would describe it as a 512, 512, 3. But in NumPy, you'd have a 3 by, actually, I should give a different example, 3, 6, 300. Yeah, so you'd have a 3 by 300 by 512. 300, 512. And Appose does not yet flip for you. I would like it to when you pass an image, but it doesn't support passing images yet, and so we need to flip it ourselves. That is where flipimg comes in. There are a number of ways of doing it. I'm just going to finish writing this out because I already wrote it. I'm going to put that up here in my flipimg. I'm not going to make it part of the doc string because I suck. And now we're going to use it. Flipimg. So we don't want to actually copy our NumPy array into a shared thing. We want to flip it and then copy the flipped one. Flipimg. Sweet. That's note. Turn these as shared memory ND arrays. Good. I will say one thing about who owns these shared objects. Like I said, when all processes end, if you have shared memory, it'll just be laying around. Appose tries to take care of, Appose's assumption is that whoever is kind of the coordinating process, in this case, that's Fiji, is the one that's going to take care of freeing up everything. So even though we made an ND array here, in Python, we're not going to clean it up. It would be something we would clean up on the Java side because this task could end and the service could then terminate and Java might still want access to that memory. And so the kind of best practice pattern that I like personally and that Appose tries to support is that you will clean up all your shared memory stuff when you shut down Fiji or when you're done with the image in Fiji, however you can swing it. I think we're done now with unsegpy. So we've now fixed the bug with the task inputs. I had that print image here. I'll just leave that for now, but I'm not going to commit that. And then I added the flip image, share as ND array, and I used them. So we fixed our inputs and we fixed our outputs. And I'm going to checkpoint that. And I'm going to naively assume that everything's perfect now and all bugs are fixed. So that's definitely the case. Okay, let's go back to PG and find out if that's actually the case. Run. Oh, Python crashed. It's interesting. I'm going to clear my error and my output because the old ones from previous runs are there and I find it very confusing. Let's try again. Because ND array is null. All right, debugging continues. The reason ND array is null is because it never came back from Appose, I believe. I wonder if I broke it. So now this is where it's helpful to run it still. Pixie run unseg. Did I screw up and break it? It's running. Okay, it did it. Well, that's a good sign. Let's try again. Nope. Let's restart Fiji. Bummer. You know what? Before I restart Fiji, though, I'm going to try one other thing. I'm going to open up my reference repository and see whether it works, because it was working from that one. So desktop, make their reference. Git clone. CT Rueden unseg Fiji. Okay, so this is the one that I had prepared in advance. I will now open reference unseg Fiji. And it's this unseg Fiji groovy. The whole point of Appose is I shouldn't need to do anything else, right? The script is standing alone. Fascinating. Worked earlier, doesn't work anymore. I wonder if something's wrong with the environment. So this is where we can try rebuild and see if that helps. I'll go back to this one since it's the same problem. And this is also where lock files are very helpful because it's possible like some new version of something came out and now it doesn't work, right? We should be seeing, I think it's working. We should be seeing print statements about what's coming from unseg, but I noticed this, that there seems to be a delay. This listen function is receiving these messages, but it's going to dump them all at once down here. That means there's some flushing issue, but the messages will appear. Hopefully, if it ever works, see if it actually errored out. Did it? It's still running, so I kill it. Clear all my stuff. Try one more time. Interesting. Oh, I bet you. I'm doing rebuild every time, right? This can happen if your environments get screwed up. Try it. Okay, now we're. Ah, some weird. This is an error I have not seen before. If you're on Windows, by the way, there's a bug with importing NumPy when you have the standard input stream open. And to work around that with Appose, when you make the service, you can import it proactively with .init and pass an init script. So that will not only import NumPy as soon as the service starts, before it even starts listening from this pipes. It will also expose that NumPy as a global variable in all your subsequent scripts. So that's pretty handy. It's possible that that will fix our issue. Well, we're just going to let that run for a while. And at this point, I would like to take questions, but I actually don't know how to take questions. I think given that it's a small Zoom call, anyone should just be able to unmute and ask, right?
Hello.
Hello.
Hi.
Hi. Well,
It's super cool, and I'm really looking forward to software with Groovy and Python. But the question I have is because one of the tools I use infamously has a dependency problem, so you need to go and manually change one of the .py files when you install it. Is this something that is feasible with the Pixie management, or?
I think so. I'm not totally sure what the issue is with the project. As you saw, this unseg tool doesn't have a package at all. So this tool that you're trying to use, you say you have to go and change one of the dependencies to a different version. Is that right?
So what happens is you pip install the thing and it installs a bunch of dependencies. One of the ones it has is called pick detect, which has not been maintained in 12 plus
Yes.
years.
Right.
So what it tries to import a SciPy function, it tries to import it from the base SciPy, and now it's like in a different submodule. So you need to go and manually just change. It's literally just change instead of from SciPy import is from SciPy.fft import. That's literally the only thing that's necessary to do.
Yes. Okay. So, I mean, this is not something that Pixie itself can do. If it's not maintained, so you have two options in this case. This is whenever there's software that's not maintained, right? You can either do some sort of workarounds or monkey patching, or you can fork it. So someone could certainly publish like their own version of this thing, which has that fix and is named something slightly different. But in this case, because Python is a source first language, you could use Pixie to install everything like you said, and then actually in your script, just go hack it. This is what I mean by monkey patching, right? You could actually like just do a search and replace in the environment site packages slash, whatever.py and fix it that way. It's super hacky. I think but if it's only your environment, then you're not like breaking anybody else's world, right? You made your own environment with your own thing, and then you fix it, and then you use it. So I think that would actually be a reasonable thing to do. Does that help?
Yeah. So we'll look into that. And maybe a follow-up is it's similar to like how we import the pixie.toml file and things like that. Can something be similar be done with like Conda Forge or Conda Environments YAML files?
I'm sorry. Can you say the first part of that sentence again?
Sorry. Here we are putting in the Groovy script, the whole thing of
Yeah.
the pixie.toml file.
Yes. Could you
If
read it?
I have instead a conda.yml or .yaml file, is
Yes,
it
I
an
see.
equivalent or?
Appose supports conda environment.yamls, and it supports pyproject.toml. It has three builders, okay? It has a Mamba-based builder, which uses Micro Mamba. It has a Pixie-based builder, which you've seen, and it has a UV-based builder. And for all three of those tools, Micro Mamba, Pixie, and UV, the awesome thing is that each of them is one single binary. And so Appose can easily download that single binary and drop it in. Let's see if I can show. So you can see here I have UV, I have Pixie, and I have, well, that's a lot more stuff in the .mamba folder, but there's Micro Mamba in there. And you choose the builder you want to use. You can say appose.mamba or appose.uv. And each builder, excuse me, each builder supports what it supports. Pixie happens to support environment.yaml files. So if you have one of those, you can say oppose dot pixie dot content, or actually file, you can say too, right? Path to environment dot YAML. Do that. You can also say oppose dot mamba, that file, path to environment dot YAML. You can also, even if you have like some weird YAML, some weird toml, then it could be a Pixie toml, or well, or it could be a PyProject toml, because Pixie sports both of those, and you say .scheme pixie.toml, and it knows it's a Pixie toml. All of these things are part of the Fluent Builder API. And then there's also a where you can just say oppose.file, some toml .scheme PyProject.toml, and then it'll use the best builder for that particular thing. So you don't even have to say .pixie or .mamba. You can just be like, here's my file, go. And there's a couple little rough edges around certain of these patterns right now, but it's mostly working, all of it, and I am committed to having it all work 1.02. So if you find bugs, please report to them. Actually, I can go to, I'm going to skip past troubleshooting tips. This is we talked about a lot of these, and these are mostly there for people who check the slides after the workshop. The main takeaway is develop your Python code standalone first and then use it. I'm really bummed that that wouldn't show you guys the final result. The Python keeps crashing because it worked earlier, but that's demoitis for you. I'm going to ask you, the group here, did anyone finish and make it work? I'm going to be sad if no one could.
For me, it crashed with the ND array thing in the Groovy script, so I'll need to fix that later.
You're on a Mac also?
Yeah.
Yeah, it might be Mac specific thing. So I developed most of this on Linux and Linux x64, and it was working there too. So okay. Yeah. So if you want to see the Oppose Builder API in action, you can go here, and then this is actually the top level repository that describes Oppose in general. But you can click into whichever language you want to use. The Python builder isn't released yet. Okay. So all of that goodness with Pixie and all of that, it's on a branch. Actually, it's on the main branch of the Python, Oppose Python right now. So if you want to write a Napari plugin and use all that builder goodness, that will be released like super soon, because I've just finished porting it earlier this week and I'm just ironing out some kinks. But for now, the Java one is the one that has all the goodness for building. With Python, you can use everything else. You can start, if you make your own environment, like from the command line, then you can wrap it by passing the path to Oppose, and then you can call service and task and all that. It still works. It's just the builder that I'm working on finalizing in Python. Okay, so here we have Oppose Java. And yeah, there's examples here. These are fine, the super minimal one, and then one that gives some task feedback. But also you can look at the unit tests. So if you go here, source test, click into there, into the builder. These are all the examples for like different ways you can build stuff. So if I look at Pixie Builder test, like here's one that passes a environment.yaml. It's called Cause. This is a Pixie toml version of it. And they're all setting the folder that they want to be in. The Pixie also has a piecemeal builder here. So you don't even need a YAML file or a toml file. You can just do it inline like this. You say Pixie, and then you say, I want that from Conda, I want that from PyPy, in this folder, go. And that works. So I feel like for projects that don't have real complicated dependencies, this is actually the nicest. But for a lot of this deep learning stuff, you're going to want a pixie.toml, like I showed briefly with the StarFun 3D that we're integrating into TrackMate, because you just need to define all this platform-specific stuff. Okay, so that's where you can find examples. I would love to hear about anybody who integrates Oppose into their own projects, and I'm happy to help. If you haven't already been on Zulip, you can go to chat.image.sc, and it will redirect you to our ImageSC Zulip. This is not really intended for asking bioimage analysis questions. We would strongly encourage you to still use the ImageSC forum for that. But for developer chat, this is really great, because you can just quickly go back and forth and paste code snippets and be a lot more sloppy than you are on the forum for things that are only transiently relevant to people. It will be under the software. You can say, there's a subscribe, where is it? There's a subscribe to channel thing somewhere, and you want to subscribe to the Appose channel. This one called Rambling Development Log is where I post just tons of stuff about what I'm doing with Appose right now. So I'll be updating this very soon with information about releases for the Python builder, and hopefully Windows bug fixes as well. So yeah, you're welcome to join there. You can post about Appose as well on the forum with tag Appose. That's totally fine. But if you join the Zulip, then you can message me anytime. Always PR is welcome. Always. I understand that it's hard to find time. Okay, yep, these are different things you could try. I already opened the floor to questions. I will open it to further questions now.
I do have a question, actually. Since this is shared memory, is there any sort of synchronization lock to prevent someone from, say, passing the same image? No? Okay.
Nothing. Shared memory by default is completely open.
Yeah, I figured, just checking.
Yeah, and the reason that I chose that, if you look at different, so there's so-called IPC, right, interprocess communication, and there's so many of these frameworks. You know, Apache Arrow, and there's so many of them, and a lot of them have really fancy stuff built in, and a lot of them let you go between computers because they use the HTTP stack and so forth. But if you want to use shared memory, you can't go between computers, and I wanted Appose to be focused on that use case, and so it just uses pipes. And I wanted it to be focused on usability and ease of use. So I impose no restrictions on locking or unlocking or needing to say try, lock, unlock, and then, oh, there's a deadlock. None of that, right? The danger is two things are writing to the same memory at the same time, and then the whole thing is hosed. But if that happens, it shouldn't crash. It should just look weird if you tried to visualize while two things were messing with something. As long as you're writing in the bounds of the memory. And you can, of course, do it yourself, right? You can, in your script, I used wait for, right, to make sure that it was done before I started visualizing anything. But I could change that script to just call start and then just repaint every so often. You know, it's a little tricky in Fiji because of the legacy of the original ImageJ. So you have your ImageLib images, which are so-called virtual images, which means that they have to copy data into byte arrays and feed them to the original ImageJ. It's because Fiji's using the original ImageJ user interface. So that's a bit unfortunate. It means it's not quite so easy to just say repaint and it'll have the stuff from Python. But it can be done. There's PyImageJ has a function, I think, called sync, ImageJ sync or something, where you give it an image and it basically forces a copy to the right byte array. So you could do that, right? You just have to take care not to, I guess, not to do it unwittingly, because then you'll end up with the wrong answer. Okay, anyone else have further questions that they want to ask about Appose or anything relating to Fiji, really?
I have 2 more questions if you want.
We have 2 minutes, so feel free to go ahead. No one else is speaking up, so.
Is there a cell image function for transferring the ND arrays? Because I saw you have the array image.
That's no, but that would be awesome. So what you would write is what's called a cell loader, right? In Java, you write these cell loaders, which populate the cells of a cell image, or the blocks, if you will, right? And you can write them to load the blocks in whatever shape you want. So you could potentially do 2 things, right? One of them is on the Java side, you could do that, and then you could have the shared memory blocks be coming from Python. And then the other thing is on the Python side, you could load blocks using some Dask-like thing from shared memory also. And it becomes tricky though, because you're saying with locking of, what you could imagine was having a full cache of shared memory blocks. I want to only ever use 1 gig, and the block size is 1 meg or something. That's probably too huge, but you get the idea. So then you got a bunch of these 1 meg shared memory blocks that are being essentially reused in a pool, and you have to do so-called cache eviction to throw away the ones that you're not using. And that can be really complicated. So we haven't built it, but I think writing a cell loader on the Java side is pretty straightforward, and writing on the Python side. Does that answer your question, or is that not what you were talking about?
No, that's what I was talking about. I was just curious if it had happened yet, but yeah. Okay.
Yeah, I think that's where we're going to go. I mean, we got to get Appose to 1.0. And then once all the layers are working well and we're happy with the API, we just build, then you're building more layers, right? Like the imglib2 Appose library becomes more fancy. And it can support CellMG. Yeah, I think ultimately that's what we really want, is just being able to feed stuff from Python and really big images, right? Because, so I will say about shared memory, you can allocate more than a 2 gig page if you want. Appose supports it. I was able to allocate something close to my machine's memory. However, the imglib2 layer is limited to 2 gigs right now because of the array img. Like if you call that like as array img function, it'll only work on the first 2 gigs of the data, which is unfortunate. So yeah, we definitely want to get the cell one working, even if it's up from one big block of shared memory, like just being able to page it that way. Good. Okay, well, with that, I will thank you all for your attention. We're at time here. So it was a pleasure to walk through that with you, except for the part where it didn't work. That was not a pleasure. But I hope someone manages to get it working. And I promise you that it has worked and the code as written works, at least on Linux, and we'll continue to iron out the bugs. So thank you very much.